Okay, guys, we're back at it. Today, we're doing H.05. And we're just going to go back and kind of look at vector equations of lines a little deeper. So here's our first example. Given point A at -5, 4 and point B at 3, -2, write an equation in vector form. Okay, we've done this 100 times. So, well, not 100 times, I'm exaggerating. But let's go ahead and put P equal to A plus P times B minus A. Okay, and then we'll put in A. We've got -5, 4 plus P times, and we've got 3, -2. That's point B minus point A at -5, 4. Okay, can you see this okay? Let's zoom in a little bit. Okay, so that is -5, 4 plus P, and you've got 3 plus 5, -2 minus 4. So the final equation is P equals -5, 4 plus P times 8, -6. Now I'm going to change these brackets. So I want you to recognize the 8, -6 is really describing a vector in this case. But let's draw this line, okay? So we've got -5, 2, 5, 4. So there's point A at -5, 4. And B is at 3, -2. So there's B at 3, -2. Okay. Oops, sorry, you couldn't see that. And I'm going to draw the line in there. So there's the line AB. Goes through those 2 points. And this is the equation. This is the equation for that line that goes through AB. Now, let's think about this. If lowercase p, so let's write this. If lowercase p equals 1, then what we're saying is take the point -5, 4 and go right 8 and down 6. Go right 8 and down 6. Because 1 times that vector component of 8, -6 equals 8, -6. So, oh, what the heck is that? Like that. All right, so if we come over to our starting point, because that's the -5, 4, that says to go over 8. So we've got 2, 4, 6, 8. And then, so this is plus 8. And then down 6. So that's 2, 4, 6. And look where I end up. Down 6. I end up still on the line at that point B. Well, that makes sense. But what happens if we change that value of P? What if instead, if lowercase p equals 1/2? Okay? So now we've got 1/2 times the vector component of 8, -6, which takes me to 4, -3. All right, so let's try that. We're going to start from the same starting place, the 5, 4. Okay, but this time, instead of going right 8, we're just going to go right 4. So that's 1, 2, 3, 4. Sorry, my hand's right in the way. 2, 4. So that's plus 4 and down 3. But notice, I'm still on the line. I'm still on the line. And let's do another one. Let's say we've got if p equals -1/2. If p equals -1/2. Now we've got -1/2 times the vector component of 8, -6. And that would give me negative 4, comma, positive 3. Okay, we still start at the same point. Sorry, negative 4, 3. We're going to start at the same point, but this time it says go left 4, 1, 2, 3, 4, and up 3. But again, bang, still on the line. Negative 4 plus 3. This is negative 4, 3. Okay, so we keep ending up on the line. And I wanted to reinforce that this is the starting point, and then this vector component with the multiplier just tells you how far up and down the line to move, but you're always going to stay on the line. All right, hope that helped. So let's get to today's example. So this is example walnut. Apparently we're doing trees today. Given the equation t equals 1, 2 plus lowercase t, 3, 4. Now, there might be some confusion here because you often see whether this really is a vector component. I suppose I should have done the brackets like this. And I know you've seen me doing it differently in the other videos. All right, so given this equation for a line, we want to, is the 0.46 on the line? Well, all we have to do is we're going to take 4, 6 and put it in for t. So we've got 4, 6 that we have put in for t. And then we write the rest of the equation, 1, 2 plus t, and then the vector component of 3, 4. And we're going to see if the left side equals the right side. Now remember, there's your x part, here's an x part, and there's an x part with the t times it. So does 4 equal 1 plus 3t? Okay. Subtract 1 from both sides, and you get 3 equals 3t. Divide both sides by 3, and 1 equals t. Okay, now let's look at the y's. Y, y, and y with the times t. So we've got 6 equal to 2 plus 4t. Subtract 2 from both sides, and 4 equals 4t. Divide both sides by 4, and again, t equals 1. Okay, because we got the same multiplier, that tells me that the 0.46 is on that line. If these two t's had been different, it wouldn't have worked. So 4, 6 is on the line because the t's are equal. Now let's try the other one. It asked if negative 5 is. Now you got to be able to guess. This one's not going to be because I wanted to give you an example of both. All right, so we've got negative 5, negative 5 is equal to, we still have the 1, 2 plus t vector portion 3, 4. All right, so x parts, negative 5 equals 1 plus 3t. Subtract 1 from both sides. Negative 6 equals 3t. Divide both sides by 3, and negative 2 equals t. So this would lead me to believe that t equals negative 2. Now let's do the y's. And you've got negative 5 equal to 2 plus 4t, because we distributed that. Take 2 away from both sides, and negative 7 equals 4t, or negative 7 over 4 equals t. Now look, the t values are different. So this point, negative 5, cannot be on that line. It just wouldn't work. So negative 5 is not on the line because the t's are different.